Okay, hello everyone. Today we'll be doing one of the most basic things in physics known as moments or moment of a force. For a do here right ahead. Now let's define the moment first. A moment of a force is described as the turning effect of the force. And so it can happen in two different directions, either, either clockwise or anti-clockwise. Now the formula for moments is moments will be beginning with a capital M is equivalent force times perpendicular distance. And we'll draw a perpendicular angle here just to show you that's perpendicular distance. Now you have to differentiate this from the equation of work, which is force times parallel distance. What this means is that we're not working out the moment of a force. The force is acting upwards. We would measure the distance of the pivot either the left or right of that force. So whichever direction the force is acting, you have to measure the distance perpendicular to it to get the correct moment. Okay, so now that we've established what that is, let's look at a very important thing you need to know about moments. When it comes to moments, they are a vector quantity. And what you need to know is that the sum of the clockwise moments, I will say sum of clockwise, is equivalent to the sum of the anticlockwise moments. So this vector property actually comes from the fact that we're using force. In this, it's distance and non-necessary displacement. The vector property comes from the force. Now let's look at a question to deal with moments. Seesaw. One side, there's a person with a weight of 600 newtons. He's sitting 3 meters away from the pivot. On the other side, is a person weighing 400 newtons. How far away must he or she sit? Now what you can be asking, how far away from the pivot must the other person sit to balance the seesaw? Go ahead and draw a seesaw. That's a pivot. Imagine that the pivot is in the middle. And so we'll be taking moments about this pivot. Now what you need to understand is that you can take moments about any point and say this thing that we're trying to measure the moment of right now, the seesaw. So if we have person A over here that weighs 600 newtons, if we wanted to, we could actually take moments from person A. But the reason why we won't do that is because we were given the distance from the pivot here. The thing about this, whichever pivot you're taking moments from, you must be given the distances of everything else from that pivot. Now over here, we'll just put person B, who is weighing 450 newtons, and we were given the distance here, which was 3 meters. Now what we're trying to solve how far away from this pivot person B must be to completely balance out the seesaw. Now, as we said before, the sum of the clockwise moments must equal the sum of the anti-clockwise moment for the system to be in equilibrium or to be balanced. So we'll take person A over here as the anti-clockwise moment. So this person is going to be dragging the seesaw down, going this way. We'll take that as the anti-clockwise moment, and this person is going to be the clockwise moment, dragging the seesaw this way. So we'll say 450 newtons multiplied by x, the distance that we don't know in meters, is equivalent to 600 newtons times 3 meters. Okay, get some more space there. And so now we can say that x meters is equal to 1800 Newton meters. Yeah, that's the unit of moment, Newton meters. Now remember, when you're doing equation that involve work, use joule. When you're doing moments, use Newton meters. They're technically the same unit, but because you have the difference in type of distance, it measures two different quantities. And we would divide by the 450 newtons. Then we could cancel out these zeros. Yeah? And 45 goes into 92 times, so it goes into 184 times. Yeah? With 4 there. And so x meter is equal to 4 meters. Therefore, for this system to be fully balanced, person B must be 4 meters away from the pivot. Now, like I said, we could have actually taken moments from person B, and then we would have this one going in the clockwise, and then this one kind of going in the same direction. But basically, you can take moments from any point on this thing. So that's the basics of moments. I'll do another video on a more advanced moment at a later date. Have a good day. Thanks for watching.
Tell me pretty lies, look me in the face. Tell me that you love me, even if it's fake.